Let's talk about naming alkanes with two or more parent chains of identical length. So you can end up with a molecule that has more than one parent chain in the molecule that has the same number of carbons, right? So let's first acknowledge that this molecule and this molecule, they are the same. I draw two of them so that we can identify one of the long chain using this one and the second long chain using this one. So if you run into a situation like this where you have two or more parent chains of identical length, then this is how you approach it. The first thing you need to do is you need to find all the parent chains of identical length within the molecule. Okay, so let's do that first. So the parent chain, one of the parent chain is this. That's one parent chain. The next one, and I'm gonna give it blue, is this one. Notice I'm not making any triangles. So that's the other parent chain. So let's see how many carbons we have, because the number of carbons must be the same. Because remember, it says parent chain of identical length. 1, 2, 3, 4, 5, 6. Cool. So we see that within this molecule, we have two parent chains of identical length. Okay. So which one of these do I pick? Do I pick red or do I pick blue? All you have to do is choose the parent chain with the greater number of substituents. So let's look here. When it's red, for the red one, right, I only have one substituent. Let's circle that one substituent, right? When it's blue, I have one, two substituents. Remember, your substituents are branch groups. They are bonded to carbons that are part of the longest chain. So your substituents, don't forget, they're not part of the longest chain. They're bonded to carbons that make up the longest chain. So we would name this molecule using the blue longest chain, this one, because over here, when we're red, we only have one substituent. Our longest chain in blue has two substituents. So to name this molecule, right, remember you click, our numbering is correct because you number from the end that gives the substituent encounter first, the lowest number. So 2, we couldn't number from here. If you numbered from this way, the substituent encounter first would have been on 1, 2, 3, 4. If you don't remember this, you can go back to how to use when you have two different substituents, okay? So our numbering, our order of numbering here is correct. So once we have that, then we need to list the substituents in alphabetical order. So I have a methyl group and I have an ethyl group. So our name is on carbon number 3 is where my ethyl group is. So it's 3-ethyl. Separate letter from number with a dash. On carbon 2, I have a methyl group. So it's 2-methyl. And then 6 carbons in my longest chain. That's the parent name, hexane. And that is how you would handle a situation where you have two or more parent chain that is within one molecule. Find the longest chains, right? And then look to see, okay, which one of these long chains have the most substituents, and then you name based on that. That's all you have to do.